I'm an evolutionary biologist. I study adaptation.
This is Dr. Joan Strassman. She gave a lecture on this channel about a really innovative definition of organism.
Organismal biology is a thing, but if you really ask people to define what it is, it's just not that well defined.
Let me show you a sort of poorly kept biological secret. If you get an intro biology textbook like this one, and you open it up to chapter 1, section 1, you'll get some kind of definition of this word organism. This one says an organism is a life form, but there is no simple definition of life that is endorsed by all biologists. This is kind of crazy when you think about it. Biologists study organisms, but there's no firm agreement on what exactly an organism is. So, what does it mean to be an organism? Let's go for a walk. So these are lichens. You can find them growing all over, usually on rocks or bark. From this view, the lichen looks like a single frilly leafy thing, but when you look at it under a microscope, it turns out that the lichen is actually two distinct creatures living intimately together, a fungus and an alga. They're totally codependent, with the alga providing sugar for the fungus and the fungus providing minerals and protection for the alga, but they have totally separate genomes and independent evolutionary histories. So the question is this integrated lichen unit one organism or two? Let's take a look at another example. It's not far away. So I have to be really quiet because the last time I was down here I got stung really badly, but in that nest that's behind me there's a whole society of paper wasps. So most of the wasps in there have completely given up their chance to breed in exchange for helping their queen to reproduce. But unlike the honeybees that you might be more familiar with, in those wasps there can be multiple queens, and there's usually a lot of conflict between the queens about who gets to occupy the top position. So we can ask the same questions about the wasps up there that we did about the lichens. How many organisms are there? Some biologists think that because the workers have given up their chance to reproduce, that the entire hive has become an organism that they are all a part of. Usually when we use the word organism, we're thinking about some well-defined creature like Maximus or maple tree. But the lichens on this maple tree show that defining what an organism is not so simple.
A lot of organisms just aren't the things you learned about in kindergarten. They're just all these other things out there, and life mostly takes bizarre forms, and we don't really much think about them.
So Joan is developing a new definition of organism, one that treats organism less like a category and more like a spectrum.
So really what I've tried to do is completely trash the sort of traditional definition of an organism and replaced it with the new definition. And we say that what makes an organism is that there's high cooperation among the parts and low actual conflict.
So in this paper, Beyond Society, the Evolution of Organismality, they make a map of different organismal forms by graphing levels of conflict and cooperation on two axes.
People generally think of high cooperation as the opposite of high conflict on sort of one linear scale. And so what we would like to say is that actually the opposite of high cooperation is no cooperation, and the opposite of high conflict is low conflict, and they're not the same. Really started trying to think that probably there's a whole lot of things that we think of as differences on one line when they're really kind of an X, and probably you can look at them in more dimensions than that.
So, on this multi-dimensional graph, the things that are most organismal would be in the upper right, with high cooperation and low conflict, but there are lots of creatures which fall elsewhere on the spectrum, into societies, competitors, or simple groups.
For example, the honeybee and the paper wasp have similar levels of cooperation. They're both towards the top, but the paper wasp has a lot more conflict because of the multiple queens, so really, the wasp is more of a society, while the honeybee is more like an organism. Similarly, modern cities, like New York here, have a lot more cooperation than tribal settlements, like this Dogon village, but they also have a lot more conflict, so they're higher and further to the left. The paper puts classic multicellular organisms like blue whales with highly cooperative cells all the way up here in the organism category. They put lichens somewhere over here, and plants with their pollinators around here. Down here is where they would put things like lions eating gazelles, lots of conflict, no cooperation, and over here is where they would put fields of dandelions and other clonal things that don't have much cooperation, but not that much conflict either. This perspective allows us to think about organism less as like a category, less as a type of thing, and more like a function. Organism is a thing that life does, an adaptation for living cooperatively.
Level of life that we call an organism is the unit of selection that adaptation works at, so that the parts have near unanimous interests. The sub-interests are subsumed into the common good.
So what an organism is a bundle of adaptations which ensures that each of the parts is aligned towards a common goal. Our eyes are too big to see single cells, so we usually ignore most of the organismal cooperation which is all around us, even makes us. Our bodies are made up of trillions of cells, every one of them working towards the shared goal of making a single organism, which we call me. It's taken 500 million years of evolution for our bodies to become this organismally integrated. So integrated that we feel, subjectively, like individual selves. But there are other kinds of selves out there in the world, and not all of them are as easy to identify as an animal wrapped in skin. Sometimes we need a bit of theory to help us notice them, but those other kinds of selves are there, and we can find them if we know what we're looking for. Hey there! Thanks for watching! This video is part of a class called the EVO Seminar Series. We host speakers like Dr. Strassman who give talks about their work, and then we make videos about them. There's a link in the description to Joan's full talk as well as her organismality paper, and if you liked this video and you want to see more like it, you can click that subscribe button, and I will see you next time.